In the third design challenge, you want students to be able to figure out whether or not they can get the satellite to spin fast enough in order for the antenna and the booms to deploy. In the activity, it suggested that you can use a rotary tool in order to get the satellite to spin pretty fast. If you're going to do that with students, I would remind you to take proper safety precautions. Students must wear eye protection, and they probably want to have long sleeves on while they're doing the experiment. In this activity, it's a good idea to build off of your previous design challenges. So in the first one, you had students design the shape of the satellite. In the second one, you figured out how you're going to put them into the container. And in the third one, now you're going to attach the antenna and the boom to the satellite. So I have my MMS satellite, and in this case, you could opt to go with whatever the students have already designed, or use the MMS templates in order to say this is what we're going to build it off of. So what you're going to do is you're going to attach string to the satellite and use that as the antenna and the boom in order to have students, one, figure out how they're going to orient that into their container to make sure that it'll be able to be launched, and then second, how fast do they have to spin the satellite in order to get those to deploy. So to start the design challenge, I wanted my students to start using some science and design an experiment. And so what I set up was a piece of cardboard where I taped on string. Now I would probably use string that was a little bit lighter than this in order to make it work, but I wanted you to be able to see it in the video. And so I have that string and it's just taped onto the cardboard, and then what I would do is I would spin the cardboard with my pencil here, much safer speed, so I don't really have to worry about things and probably wear my eye protection. I can also take my satellite and fit it right on top so that I get a better sense of what is supposed to be happening here. Now when you move to testing these out with the rotary tool, I would strongly suggest having the teacher do this, or an adult in the room, rather than allowing students to do this, because it can be dangerous. If you're looking for a way to be able to measure how fast it's going, the rotary tool may have some settings that you can use, but a rotary motion sensor will also do the trick. You can take this sensor and it will measure how fast something is spinning, and that's really the answer that you're trying to get at, so that you can tell the scientists, hey, this is exactly how fast I need my satellite to spin to deploy the antenna. And once again, it's critical that students are using some type of journal, log, or blog in order to record their work as they go through. And as a part of that journal, they want to be taking pictures along the way and collecting data that goes into their report. And then finally, how are students going to report out their answer to the design challenge? So it's not enough that they just take their idea and say, this is what we've come up with. They should be able to present it some way so that others can look at it, follow what it is that they did, and how they achieved their answer.